first section in chapter 12 that we're going to talk about is tangent lines. And so, first knowing what a tangent line is. A tangent line is where a line will intersect a circle at one point. So the letter P that you see there, that is where it's tangent at. So this first theorem says if a line is tangent to a circle, then the line is perpendicular to the radius at that point of tangency. So if I know this line is tangent, then I know that that makes a right angle right there. So what we can do is use that theorem to find what the angle measurements are within certain figures. So it gives us that ML and MN are tangent to circle O, so it wants us to find what angle measurement this is. So keep in mind that if these lines are tangent, then I know that at this point of tangency there's a right angle, and also at this point of tangency there's a right angle. So I could figure out what that x would be by just subtracting from what the sum is. So if I have a four-sided figure, remember that all of those interior angles will add up to 360. So you could just take 360 minus 90 minus 90 and minus 117 on your calculator, or you could set up an equation which does the same thing. Add up all of those numbers and then subtract from 360. Either way, you end up with the same answer. So whether you would like to set up an equation or just put it in your calculator, that's up to you. Okay, pause the video and try the got it question. So in the got it question, we only have a three-sided figure, so that means that my interior angles will add up to 180 this time. My point of tangency would be at D, so there is my right angle. So I would add up 90 and 38, which is 128, subtract it from 180, and you should have gotten 52. Okay, so the next theorem says, if a line in the plane of a circle is perpendicular to a radius at its endpoint on the circle, then the line is tangent to the circle. So what it's saying is, if you can verify that these are right angles, then I know that that line would be tangent. So, here's my first problem. It says BC is 8, BA is 4. What's the length of AC? Well, if this is going to be tangent, I could just go ahead and assume this is a right angle, and then I could just use Pythagorean theorem to find that missing length. So I would put 8 and 4 in for A and B, square those two, add them up, and then do the square root. So approximately AC is 8.9. Okay, pause the video and try the got it question. So in the got it question, it asks, determine whether a tangent is shown in the diagram. So this is a similar question to what we just did, except on the previous it asked you to find the missing length. Here they give you all the lengths, and so you would have to check if it's going to be tangent, all of those would have to fit in the Pythagorean theorem. So I put 5 and 15 in for A and B, and I put 16 in for C. Then I solved it. So I squared all of them, added this left side, and got 250 on the left side and 256 on the right side. Since these are not equal to each other, that line cannot be tangent, meaning right here, this line would not be tangent to that circle because it does not form a right angle. Okay, so on the next theorem then, it says if two tangent segments to a circle share a common endpoint outside the circle, then the two segments are congruent. So what it's saying is, if it looks kind of like an ice cream cone where you have the circle as the ice cream and here is your cone, then the lines that form the cones have to be congruent to each other if these two lines are tangent. Okay, so here's a picture down here. It tells me that PQ and QS are tangent to each other, and then what's the value of X? Well, those two lines have to be congruent if PQ and QS are tangent. So we're just going to set those two equal to each other and solve. So I minus 2x from both sides, and I got 1x plus 6 equals 9. Then I subtracted 6 from both sides, and I got x equal 3. So the first part is just about tangent lines. So remember, a tangent line is just where it touches at one point on that circle, and then there's several theorems that apply to that. So depending on what kind of picture it gives you, depends on what theorem you would use.